Hi, I think square wave voltammetry is a super intriguing method for doing electrochemical analysis. It is something that we use ourselves. You've got these kind of parameters, you've got this start potential, so you can't, depending on your electrochemical system, the start potential and the stop potential are kind of things that you haven't got that many parameters to play with. So what I mean by that is I've got a solution of ferrocyanide in front of me. So if I want to find the oxidation wave for ferrocyanide to ferricyanide, then starting at minus 200 millivolts and scanning to 600 millivolts is fairly reasonable. The 5 millivolt voltage step means that we're not really doing a analog signal where we're kind of changing from minus 200 to 600 millivolts. We're doing it in 5 millivolt steps. So if you overdo it, you can lose some of the details, and if you underdo it, the experiment maybe sort of takes too long. The current range is something that, depending on your kind of concentration of analyte, I'm doing 5 millimoles of ferricyanide, so 100 micrograms, which kind of makes sense. Now the amplitude and the frequency are the kind of intriguing, if I can put it that way, settings. So what I want to do tonight is sort of show the impact on frequency. So I've got essentially Julie up in front of me. So Julie talks to our sensor or potentiostat, and I've got some 5 hertz data here. But I want to record some more data, and then I'm going to overlay it. So bear with me for a second whilst I just go to here. And what I'll do now is I'm just going to go to my my setup in front of me. So I've got a 5 millimolar solution of ferricyanide on there. I've got my app here. I just need to turn this on. And I'm just going to do a quick settings check. So I've done a 5 hertz experiment. I didn't want to really do that. I didn't want to make you sit through the 5 hertz experiment because it doesn't make for a very interesting video. But I'm just going to do a 25 hertz experiment now. So I'll go to my settings. I'll get my frequency up to up to 25 hertz. Yeah, so I've got my settings up to 25 hertz, and now I'm going to do exactly the same experiment, but now I'm at 25 hertz. And I'll do is at the end of this, I'll overlay all my data so that you can kind of see the impact of frequency on the signal. So this is, I've done 5 hertz already. Because the frequency was low, it took a little bit longer, so I didn't want to record that one. But I'll do 25 hertz, then I'll probably do 50 hertz, then 100, and then 200. So only a few more seconds. It'll probably say upload complete in a minute. Upload complete. Okay. Now I'll go to, I'm going to change the file name to 50 hertz, so I can find it in a minute. Then I go continue. I'm going to do the settings here to 50 hertz. Right, and now it's only going to take about 14 seconds to do that. So it's now I'm now gathering this, essentially the same experiment now, but at a much faster frequency. There we go. Right, done. Now I'm going to set it to 100 hertz. So I've changed the file name to 100 hertz. Yeah. So I've set that to 100 hertz. Off it goes. Very quick experiment. I do like quick experiments. I say it all the time, but make your assays fast, do your science quickly. If it's not going to work, I'd rather find out quite quickly. And also, I mean, if I'm going to develop an assay, I want it to be quite quick. This is what people don't want to be hanging around for your science to complete. Nurses, doctors, whoever is the final user of some of your science, wants that. They don't want to be waiting, 20 minutes for your experiment to have completed. And then I'll just do 200 hertz at the end here. And off it goes. And then what I'll do is all that data will go to Julie, and so we'll be able to look it up. And Julie says upload complete. So I did something like, I don't know, 4 or 5 experiments just then, and now the data's gone to Julie. So if I just go to here, I'll do a quick refresh. Right, so there's my 5 hertz. Let's see what pops up now. Right, so there we got my data, so I'll overlay it. So let's take the 5 hertz, the 25 hertz, the 50 hertz, the 100 hertz, and the 200 hertz, and we will combine it in one report, which I am doing. Hopefully I've hit combine. Yeah, here it goes. And once that's done, I'll just turn this off for a second so we can see what I'm up to. I just want to show that data now, so I can go here, tools, I can see all my data's there, properties, this is discrete, so it's going to extract it, and we'll have a quick look at that. Yeah, so that's quite interesting. Yeah, see, so it's really interesting actually. So it's if we turn off the 200 hertz, you can see what's going on here, that at 5 hertz, you know, there's a certain, you know, we did get the peak. At 25 hertz, we did get the peak. But you can start to see that this non-specific part of the signal, so the sort of signal is really here, but this becomes increasing with the frequency. Now at 200 hertz, I think the whole thing is just going so fast, it's just kind of falling down, let's say. So I turned that one off quite quickly. The one that looks most peak-like, I would, dare I say, it would probably be the 25 hertz. I mean, that looks quite nice. The 50 hertz. See, the 50 hertz is actually quite usable. You know, what I mean by that is, if I'm trying to develop an assay, you know, then there's still, you know, good signal in there. If you're trying to make an academic paper, I could understand that, you know, maybe you'd be a bit more, you know, wishing the 25 hertz. Let's just look at the 100 hertz. See, the 100 hertz, this, you know, we at ZP could deal with that because, you know, we'd like our assays to be quite quick. But that's, you know, it's a quick way of kind of showing you that you could argue here that, you know, I've done about 1, 2, 3, 4. I did at least 4 of those experiments live in front of you. I didn't do the 5 hertz in front of you. 5 hertz, slow, small signal, not so interesting. Turn it off. 200 hertz, just a bit too crazy. Turn that off. 100 hertz, you're sort of left then. And if I just turn off, in fact, I meant to turn off the 5 hertz. So you're kind of left with a choice between 25 and 50, and I think really the 25 is better. So that's a kind of quick experiment to sort of tell you why 25 hertz is the more interesting frequency to use. If you've got any questions, I suppose, you know, don't hesitate to reach out to us. Okay, thanks very much.